Hello everyone, my name is Daniele, and I'm here today to talk you through some of the new features that have been introduced with the second version of Android Wear. I work as a software developer, an Android developer for Novoda, which is a mobile consultancy with offices in 4 cities across Europe, while the UK is still in Europe. And I have a bit of experience with wearables, because before joining Novoda, I was working for an Italian company called iWatch, which was one of the first involved in the development and manufacturing of smartwatches. Back in the days when we were working on this project, Android Wear was not available. We were doing everything with a custom ROM of Android. But lately, in 2014, Google released Wear, which is the version of Android specifically designed with wearable devices in mind, specifically speaking regarding smartwatches. Android Wear, since the beginning, had 3 main models, let's say, of user interactions: notifications, applications installed on the watch, and watch faces, which are a subset of applications, but we will see later why they are so important. Notifications are, in general, for Android, one of the most important user experience elements. And in Android Wear, the integration of an existing app running on the phone is damn simple. Every notification that is displayed on the phone is, by default, mirrored on the watch, without any work required from the developer. So if your application already displays some notifications on the phone, you don't have to do anything to have it working out of the box on the watch. You can obviously do some more steps, add some more features to these notifications to make it even more rich for a watch. In Android Wear 2, of course, this still works, because it's a very important thing, but there are some changes in notifications. The first is related to the design. As you can see here, we are comparing the design of Wear 1 and Wear 2 notifications. You can see that the style is using a more dark theme, dark palette, which we will see later is used also in most of the installed applications on the watch. The core elements of the notifications are always the same, so you don't have to change any field used to create and to display notifications on your phone. One of the new things that have been added, anyway, are inline actions. Android Wear, in the previous release, was using a swipe gesture from the user in order to access all the actions added to a given notification. So the user, in the notification stream, could only see some text and the information that we saw before, but to access some actions, needed to scroll 2 different pages. With Android Wear 2, we can add inline actions, which are displayed straight away in the notification stream. This allows the user to interact even faster, even quicker with the notification. And you have to remember that low interactions and quick interactions are one of the core concepts when talking with Android Wear and wearables in general. This is how the notification is displayed when it's in the stream. When the user clicks on it, the expanded version is displayed. So the user can access even more information, more data, more text, even pictures if you want. But most interestingly, the user can also access to more actions. Those actions are displayed, if more than one, in the so-called action drawer. You can think of it to a component similar to the overflow menu in a typical phone application. So you click on the expand button, and you have all the actions in line. And then the user can select directly those without even leaving the home screen of the watch. The user doesn't need to go inside an application. Speaking of applications, as I mentioned before, Android Wear always supported installed applications, like full-fledged applications installed on the watch, with, of course, some limitations. But the most peculiar thing was how those applications were installed. In Android Wear 1, the watch always needed to be connected on a phone in order to install applications. The phone was the only component, the only actor that had direct access to the Play Store. So usually, the user who was browsing from the phone or the web for application to be installed. The main application was installed on the phone, and then the package manager was responsible to extract a secondary APK, which was the actual phone one, which was then forwarded to the watch and installed. In Android Wear 2, this changes because the watch now has direct access to the Play Store. It also includes a specified, a watch-specific version of the Play Store. So the user can actually browse all the available apps directly from their wrist. In order to make your watch application, if you have one, already compatible with this new system, you just need to add a new metadata flag in the application manifest. This is needed in order to make Android Wear aware the fact that your application can run as an independent or semi-independent application. I say semi-independent because, for example, your application could provide only a subset of their feature if there are no phone connected, and maybe other features when the phone is connected. The important thing is that when you set that value to true, your application will be visible through the Play Store installed on the watch. If you want to keep your application compatible with all the watches that didn't receive the update yet, and we know that some watches will never receive it, you can do that with a different flavor, setting the value to false, and also you need to specify in your build.gradle file different minimum SDKs. In this case, for Wear 2, the minimum SDK is 25, while for Wear 1 is 23. Connected to this new level of independence, let's say, of the watch, there are also new possibilities for installed applications. Regarding network connection, in Android Wear 1, the watch always required the phone as well to make any network request. You could not make a direct request to an API from the watch. You always needed to do it from the companion app installed on the phone, and then forward the received data to the watch through Bluetooth or Wi-Fi. In Android Wear 2, finally, you can access directly any API, performing any network request directly from the watch. There are some limitations, though, mostly due to the fact that watches have a very limited amount of resources, as you can imagine. Smaller screen, but especially smaller battery. So the system tried to always connect to a more power-friendly, let's call it like that, network, which usually is the Bluetooth one. If your application needs to download a bigger amount of data, and you need to think carefully if your application really needs it, you can always request your user to access a more powerful network, for example, using 3G for the watches that support it, or Wi-Fi directly. Always talking about installed applications, we mentioned before that there are some changes in the UI, in the styling of those applications. And the biggest change is the usage of darker theme over a light one. This is done in all the installed applications on Android Wear 2, and you should do it as well in your applications in order to keep a consistent look across all the apps for the user. And also, this also have some practical reasons. Some displays, like OLED ones, performs better and consume less if are displaying darker colors. So this is a good thing to keep in mind. Another thing to keep in mind if you are approaching the development on smartwatches is the different form factors for the screen. We are used to have always rectangular screens for our tablets or phones. But on watches, actually, most of the models have round displays. And if you try to use regular layout like we were used before, you can encounter some problems, like this one you can see. In round displays, the corners are, of course, cut, so you cannot display anything there. There are, luckily, some UI elements that have been introduced that allows you to automatically align and to keep all your UI elements in the screen. One of these is the so-called box inset layout, which is a view group that automatically align all the children, applying the right inset in order to keep them always visible in the screen. In this case, you can see that all the elements are visible in any case, both if you are running on a square screen or in a round one. Finally, from Where 2, it's also possible to specify some resource qualifiers depending on the form factor of the screen. So for example, you could have different layouts, but even more interestingly, you could have different dimensions, so different paddings, different font sizes, depending on the form factor of the watch you are running on. One of the most interesting new UI element is the wearable recycler view. You might be familiar, I hope so, with the recycler view, the traditional one, and you might be using one already in one of your Wear applications. If you want to update, and we will see later why you might want to update, from the previous one to the new wearable recycler view, it's just a matter of changing the tag in your layout. Simply change it from recycler view to wearable recycler view, and you will have a lot of things for free. One of these is the better support for round displays. So for example, with the wearable recycler view, you will automatically have some animations which are designed for round displays. For example, the children of the recycler view will not animate straight from top to bottom, but they will do a curved motion, better suiting the round form factor of the display. In order to implement also other features, it's possible to, for example, specify a custom layout manager, which allows you to perform other small let's say, customizations. For example, in the animation you just saw, the children close to the edge are smaller compared to the selected one, which is highlighted. This is done simply by overriding the, what's the name I don't remember, update child method, which allows you to change the size and scaling every children depending on its Y position. Another thing that is introduced in the recycler view, always with round screens in mind, is the circular scroll. You might remember this from old devices like iPod. Oops, sorry. Oh, come on. Let's see if I can show you the animation. Yes. Basically, enabling circular scroll allows the user to scroll very quickly with a single gesture instead of doing multiple vertical gestures, long list of elements. It's worth noticing that, as you can imagine, this performs best, and in general, wearable recycler views should be used for long lists of similar elements. You should not use it for small lists or lists of complex elements. How to implement this is very simple. You just need to specify, to enable it, and then specify some other parameters, like, for example, the speed of the scrolling while the user is moving his finger. Another UI element that has been introduced is the so-called navigation drawer. Navigation drawer, wearable navigation drawer is the complete name, is the Wear version of the navigation drawer we are used to on phones. As you can imagine, the UI UX is different, and as you can see, they introduced in material guideline this animation from the top, showing the list of pages, and then selecting them by just tapping on the related one. Similar to this one, but more related to actions that can be performed on a screen, is the action drawer. Action drawer is very similar to what we have in notifications, as we saw before, and basically allows the user to access several actions, plus an inline one, to be performed on the current screen. Again, you can think of this as the overflow menu that you can have on a toolbar on a traditional phone or tablet app. But it's not only software related. There are not only software related features that have been introduced with Android Wear 2. Most of the new watches, for example, spot more physical buttons. And while when the watch is idle, those buttons are usually related to launching specific apps that you can customize. Those buttons can also be used by third-party applications, intercepting when the user is clicking on those. For example, you could have a button triggering an alarm clock or a timer or something like that. To intercept them is as simple as overriding the on-key down method in your activity. And as usual, you will have a key event with a specific key code depending on which button has been pressed. For now, there are only three buttons available, so 3 key codes available that you can receive. But if you want, for example, to display an onboarding or some description in order to teach your user how to use those buttons, you could also query the system to get more information regarding those buttons. For example, you can get the number of buttons available, and you can also have information related to the position of those buttons in the watch in order to show some icon, and of course, the related icon, which explains to the user which one is which, and so then you can explain which function is associated to each button. Other watches sport a different kind of input mechanism, which is similar to what we are used to on traditional watches, which is basically a scrolling wheel, similar to the classic crown that you can find in some watches. While this one already works for every scrolling view, for example, recycler view or list view, we can also use it to, for example, increment some values instead of having the user to swipe or touch the screen. And to do so, again, is very simple. And we can do it easily, attaching a generic motion event listener to any custom view, or overriding the specific method on your view. Again, you can query the rotation encoder method utility class in order to get if the given event is coming from that wheel, and then update your UI accordingly. So we saw so far 2 of the main user interactions available on Wear: notifications and installed applications. We will see now something that has been introduced in Android Wear 2, which is related to the third user interaction that I mentioned before, which are watch faces. Watch faces deserve, in my opinion, a specific topic because they are the most popular applications out there for smartwatches, and for a good reason. Watch faces are displayed when the phone is idle, when the user is not using it, and so they are displayed for most of the time. You can think of watch faces as wallpaper, desktop wallpaper for your watch. What Android Wear 2 adds are the so-called complications. Complications is not a new word. It's a term that comes from classic watchmaking industry. And it means basically to display any other information on a dial of a watch apart from the simple telling the time. So for example, you can see on this watch, you have more data displayed. You have the time, of course, but also you have a calendar, a moon phase indicator, and I think a power reserve as well, just because. So complications are, well, complication is not a new word, but also complications are not new to the Android Wear world. In Android Wear 1, there were, and there are, thousands of watch faces that already display additional information, so using the so-called complications. In this case, for example, we have 2 examples of watch faces. One is showing, for example, the battery level, and the other one as well. This one is also showing the temperature and a calendar. The problem with those watch faces is that every single watch face developer needs to implement their own logic to fetch those information. So for example, if there are 2 watch faces showing the weather forecast or showing the temperature, each watch face should implement the same method, maybe calling the same API in order to get this information. What Android Wear 2 does is to basically put into communication applications and developers that provide data to applications, watch faces, that are going to display this data. And this is done through the so-called complication API. These are the three main actors involved in this API. Android Wear is, of course, the system, requests the data provider for updated data to be displayed. This data is fetched with the logic known only to the data provider. Can be an API call, can be some static data stored, can be whatever. The data is then bundled and sent back to the Android Wear. The data provider doesn't know where that data is going to go, because it's Android Wear only that knows the watch face that requests the update of the data. Again, this is very important because the data provider doesn't know where the data is going to be displayed, and especially what's the theme that is going to be displayed. For example, an watch face could have a completely, analog theme in order to display, I don't know which kind of information. Another one could have a totally digital one with different theme, different fonts, different colors. The data provider doesn't care. At the same way, the watch face doesn't know who is going to provide that data and which kind of data. So how they could communicate in the blind, let's say. Complication API defines the so-called complication types. Those are the communication protocol used in order to put into communication providers and watch faces. So a provider can provide, as the name suggests, data using one of these 6 available types. So for example, we could have small text complication, which are used, as the name suggests, to display a small amount of text. You could have a long one. You can have small images or big images. Every single type defines at least one required field. So a complication data provider, which supports, for example, short text, needs to provide the short text. It's possible to provide also additional one, for example, a small icon or a secondary text, but the first important one needs to be present. At the same time, one that is providing a small image needs to provide that one. It doesn't matter if it provides also text, but the image must be there. Again, these are basically defining what one is providing and what the other actor, the watch face, is receiving. Let's have a look now at the first part, which is who is providing, who is creating the data. Data providers are basically services, and as every service, you have to define them in your manifest. It's important to specify this action, which basically tells the system, hey, this service is going to provide some data for watch faces, and especially is providing this type of information. So the system already knows that the system needs to query this data provider only when requested for short text and icons. If the watch face requires for large icons or, I don't know, big text, this data provider is not queried. Another thing worth notice is that you need to specify the update period, which is, in theory, how often your service is going to be queried. I say in theory because this is not a guarantee. It's an indicative value, because the system will optimize, of course, for power consumption and might delay a query update. So you cannot have, you should not create a service that requires a strict update. And as well, you need to consider that this update process will wake up the system, so you should put it as long as possible, usually in minutes, if not hours. Inside service, there are 3 main methods that you may want to override. The first one notifies you with a callback when your complication has been added, and we'll see later how, to a watch face, so that you can start any background service or any logic you want to do to start fetching the data. Once that is done, your service will be asked to provide updated data. And this is the most important method, as you can imagine, which is on complication update. This is where your service needs to provide the complication data, which will be received by the watch face. Finally, your service will also be notified when your complication is not displayed anymore, because, for example, the user changed in order to use another provider, or when the watch face is not active at all. So you will have a callback for that. Again, as I said before, the on complication activated, which is wrong. This one is updated. Basically, is the most important method. This one is the one that provides and bundles, as you can see, the data inside a complication data. As you can see here, we are checking, because we are receiving which is the data type. So in this case, for example, we are checking for short text. And depending on that one, we are adding we are adding the main requested type, which is short text, but we can also add some optional one. For example, an icon. The watch face can decide independently if it wants to show also the icon, but it must show the short text, which is the needed data for this complication type. And then the complication manager is notified that it's time to send a new updated data. So we will see now the other component in this process, which is, of course, watch face. When we are developing and designing before a watch face, we need to think of how complications are going to be displayed. And to see that, I'm going to show you a couple of examples from traditional watchmaking. Complications are, as I said before, additional information which is displayed on dials of watches. This information can be added as using sub-dials, which are small sections of the dial used to display single specific kind of information. Or it can be displayed using windows, as you can see in this case of a calendar. Or again, it can be displayed using the full dial, using, for example, an additional hand, in order to display, in this case, a second time zone. In your design phase, you should do the same considerations, creating the so-called placeholders. Placeholders are a subset of your watch face UI, which will hold and will display the complication data that we will receive. It's important to notice that those placeholders must not distract the user from what is the main purpose of the watch face, which is telling the time. So of course, telling the time is still the main function of a watch, and so the watch face should do that as a first option. Then the user can also access more data to the complication. Again, another thing to consider is that these placeholders need to be consistent in the design with the full theme of your application, of your watch face. So, what do we need to specify for every placeholder, for each one? Which is the one that the data provider will receive, but most importantly, the watch face will receive back with new data. So we will see later, when we will receive new data, it will be associated to a given placeholder ID, so that, for example, I know I have to display in that part instead of the other one of the watch face. Then we need to specify which are the types supported. This is because, for example, a small placeholder like this one could only support short text or an icon. A bigger one, like this one, could also support, for example, larger text, because, of course, it's bigger. The user can then use your watch face configuration activity in order to specify for every single placeholder what to display. So this is something that you have to develop as a configuration activity for your watch face, but then you can invoke the system chooser, which, again, it will filter for all the content provider installed, for all the data provider installed, only the ones that are exposing data which is compatible to the selected placeholder. So for example, here, if the user selects this one, which was one of the small placeholders, here the user will see only the data provider that supports small data and icons, because we said only those can be displayed there. And there could be also more kind of data provided by a single provider. So here you will see all the applications, and then you can see you can have more items for a single data provider. This is how you call this data provider chooser from the system. You need to specify the watch face component, the complication ID, which is the placeholder ID basically, and a list of types that that placeholder will support, so that the system will filter those. This is an ordered list, bear in mind. So that it means that the data provider will receive one single callback from including the first one of these types. So this is the most important one, second important, and the last one. It's good to use this system activity because it will take care of requesting the needed runtime permission for the user if it's not granted already. In your watch face, in the onCreate of your engine, you need to specify that complications are active, specifying the different IDs of the placeholders. And then when you will have a callback on the complication data update, you will receive again the complication data that we saw before, created by the provider, and the complication ID, which is, again, the placeholder that we will use in order to display this data. You need to store this data because the actual display is going to happen in the on-draw phase. In that case, you need to check if the data you stored is still active, because, for example, you could have an update every 10 minutes, while the on-draw happens at 60 frames per second, so 60 times every second. You need to check if the data is still active, and in that case, you display it. Again, one last thing is that complications can be interactive. The user can actually click on one of the placeholders and access advanced additional features provided by given by your providers. And to do so, you just need to add a pending intent to your complication data, which we can check in the watch face, and to trigger it when the user clicks on the given selected placeholder. So we saw these three elements, which are part of the new complication API, and we saw some of the new UI element and UI and UX, especially elements introduced in notifications in Android Wear. There are a lot of other new things that have been added, and I invite you all to have a look at the samples and to the official documentation on Android, which is full of, again, examples and other things, other principles to be considered when developing Android Wear application. And with that, I will thank you, and if you have any questions.